Hello everyone, welcome back to STR8CHEM. In this video, we're going to learn about the moles concepts by using a mnemonic MAMOVONO. Ma stands for mass, MO for moles, VO for volume, and NO over here refers to the number of particles. MAMOVONO. By using this mnemonic, hopefully you will be able to find that moles concept is not difficult to be understood. So before we're going to proceed further, I just want to introduce you to the person that was responsible for the idea of moles concept. So the person is the Amedeo Avogadro, and later on you will look at a constant that will be named after him. Now, basically the concepts of mole concepts stands for the idea of 1 mole of a substance. The key point over here is 1 mole is equivalent to a very huge number, which is 6.0221415 times 10 to the power of 23 elementary entities. This is, again, I repeat, a very huge number. Okay, so if you can imagine that this as a very big number, now you can imagine that if we say 1 mole of something, or 1 mole of atoms, 1 mole of molecules, we are talking about a lot, huge lot of atoms and molecules. And the keyword entities over here refers to, in this case, atoms, molecules, and ions. Okay, so this is the number that will be the Avogadro's number. Therefore, in essence, the Avogadro's constant will be the same number, but constant over here will have the units of per mole. So that means in each mole, you will have 6.0221415 times 10 to the power of 23. So this is the Avogadro's constant. It will be a very important constant when we are talking about the MAMOVONO relationship. Okay, so in exams, you do not have to memorize this number. It will be provided to you. Or if you do not want to write the whole thing, you can also write this 6.022 times 10 to the power of 23. That should be okay. Now, how are we going to use the MAMOVONO mnemonic? Remember, Ma is for mass. When you remember Mo, that is for moles, it will be in the middle of this T or intersection over here. And No stands for the number of particles. And the one down here, Vo, is for the volume of gas. MAMOVONO. Okay? So MAMOVONO. Right. So the relationships between all of these mass, moles, number of particles, and volumes can be described as this one. So when you go out, so we're going to take mole or moles as the center point. So if you go out from mole, okay, you go out from mole, it will always going to be times by something. Okay, if you go out, it's going to be times by something. So if you are going out from moles to number of particles, you're going to times that with the Avogadro's constant. Then you should be able to change from moles to number of particles. Okay. So from moles to mass, you're going to times that with the molar mass of the species that you want to know what is the mass. Okay, they're going to give you the number of moles of a particular atom, substance, entities, and you're going to multiply that with the molar mass to get the mass. And if you want to go back to moles, remember, if you go back like this, that will be the opposites of multiply. So you're going to divide by what? You're going to do the same thing, okay? You're going to use the same thing. So you're going to divide by molar mass over here. And right there is the Avogadro's constant. So it's pretty simple for the relationship between mass, moles, and number of particles. So for the volume of gas, it's slightly more, not complicated, but you have some additional stuff you need to consider. But still, it's going to be using the same foundation, in which when you go out, you're going to times. When you go back to moles, you're going to divide that with a certain number. So it all depends on the situation now, because for you want to change from moles to volume of gas, you have two conditions that you want to consider. So the first one, maybe you want to consider at the STP or room temperature. Okay, STP stands for standard temperature and pressure. Right, so this is basically the interrelationship between the ma, mo, vo, and no. So this is the complete relationships or diagram between the mass, mole, molar volume of gas, and number of particles. So remember, when you go out, you're going to times. When you go back to moles, you're going to divide. Okay? You go out to mass times with molar mass. From moles to number of particles, you're going to times with the Avogadro's constant. And you want to go back, still going to be using the same variables over here. And this is the one that I was talking about just now, the relationship between moles and volume of gas. When you go out from moles, you're going to times with a certain number depending on the conditions. For standard temperature and pressure, you're going to take the number of moles, you times with 22.4 liter per mole. And if you want to talk about room temperature condition, if you want to change from moles to volume of gas, you're going to take the number of moles and times that with 24 liter per mole. So you have to be careful. You have to read the question. You have to know which condition that you need to be considering. Okay. So standard temperature and pressure. Standard temperature and pressure is defined as 270 Kelvin or 0 degrees Celsius and at 1 atmospheric pressure. So at STP, 1 mole of gas, we're always going to occupy 22.4 liter of the space. Okay, so if you have this temperature, this temperature, and that pressure, that means you need to be considering STP, and you need to use this number over here when you want to find out the molar volume of gas. Whereas for room temperature, they will not going to be mentioning these two informations over here. So when you have room temperature, the one that you need to consider is this number. Let's have a look at example number 1. Over here, the question wants you to find out the number of molecules and atoms. Two things that you need to do. So first, you need to find the number of molecules, and you have to find the number of atoms in the 4.5 moles of H2SO4. Okay, so mole is given to us already, right over here. So that is the number of mole given to you. So what you need to do is now you take the number of moles. So we're going to start from here. The number of mole is given to you. So that is 4.5 moles right over there. And the question wants you to find the number of molecules. So if the number of molecules, are you going that direction or to the left or to the right? Obviously, it is not going to be the mass. It's not going to be the volume, but you need to find the number of molecules. It is the no. Okay, so you are trying to find the no over here from the given mole. So we're going to go to this direction. So you're going to times this number with the Avogadro's constant to find the number of particles. Remember, you need to find the number of molecules first. So this is the molecule. H2SO4 is the molecule. Okay. So that is the answer for the number of molecules. You're just going to take the 4.5 mole times with the Avogadro's constant, then you get the number of molecules. So this is how many H2SO4 molecule. Remember, this whole thing over here, that is the molecule, okay? So in 4.5 mole of this whole thing, you have 2.7099 times 10 to the power 24 molecules of H2SO4. And we're done with the first one. So we have found out what is the number of molecules. What about atoms? Okay, so we're done with this number of molecules. Now we need to look at how many atoms inside 4.5 moles. Now, you do know that in one molecule of H2SO4, we have how many atoms? We have 2 H atoms, we have 1 S atom, and we have 4 O atoms. So 2 plus 1 plus 4. 4, 5, 6, 7. So in this one molecule, over here, we have 7 atoms. Okay, so we're going to take the 7 atoms. You're going to times with the number of molecules, and you'll get this. Okay, so the number 7 over here refers to 7 atoms in one single molecule. And remember, in 4.5 moles, we have a lot more H2SO4 molecule. So this is the number. Remember, in 4.5 mole right now, you have this many H2SO4 molecule. So when you want to find atoms, times by 7, then you'll get the number of atoms. Let's have a look at another one. Now, this question is kind of similar. So you need to find how many moles of ammonia, and it's already given you the number of molecules. Remember, we have to know that this is the molecule. So we're going to move from here, number of particles, molecules, and you want to find mole. So if you move from number of particles to moles, you have to divide with the Avogadro's constant. Okay, so how do we do that? You can do in this form. Doesn't really, it's the same concept. You have 1 mole of ammonia has 6.022 times 10 to the power 23 molecules. So we have talked about this just now. In 1 mole of ammonia, we have 6.022 times 10 to the power 23. But this time, you have how many molecules? You have this 1 mole of ammonia equivalent to this. But we want to find out for, I'm going to use a different color for that one. We want to find how many moles in that, in 2.89 times 10 to the power 24. So it's quite simple. Just look over here. You have the number of particles, 2.898 times 10 to the power 24. You just need to divide with the number, the Avogadro's constant. So this is the number of particles that is given to you. And we just divide with the Na over here. Okay, so that is the Avogadro's constant, and you get your answers 4.812 mole of ammonia.